All right, welcome back to the Pokemon API manager that I'm building as a RESTful API. um, just real quick, things that I had done while. Hang on a second. Something's wrong. Oh, okay. All right. For a second, I was like freaking out. Okay, so real quick, things that I have done while off screen to set up for this. I built all the resources or the interface, well, the map stuff for the objects that we're going to be getting from the Pokemon API. If you remember when I pulled it up, down here, all these objects that we're using for a Pokemon. Let me go down to the Pokemon. I have built these objects off screen. If you remember, I was working on them at the end of part 2. So I just did them off screen to save time. But I do have them all here, and you'll notice that I also did do the JSON property mapping, so that way when I get them, they should match the object name from what I get from the API to what I have named them without incident. So we'll have to test that and make sure it's set up right when we get to the part where we are pulling data. I wanted to start off with apologizing for not doing part 3 right away. At this point, now that we kind of have what we're getting back from the database, in this case the data service, once I map that out, the next question becomes, well, what do you do with the data? Like, what is the front end piece going to do? What is the purpose of building this? Because as I mentioned before in the N-tier development, or the N-tier architecture talk, I mentioned that this is your logic piece, the middleware, the manager that we're building is the logic. So your logic needs to know what you're doing. Like, you need to know what you're going to build with it. And I didn't have a clear answer for that until actually earlier today. I talked about possibly with my friends. I talked about possibly doing like maybe a Pokédex, but Pokédex has been done, 100 times. There's been hundreds of Pokédexes written, so that didn't seem interesting. One of my friends recommended maybe a type comparison chart, which, I mean, you can just Google it, and it takes a few minutes to just, get your dual type advantages set up, which not hard. And then I thought maybe a battle simulator. That's, again, simple, and there's a lot of different things that can go into it, but it's been done. I mean, the games are a battle simulator, so there's no point in that. So what I ended up coming up with is a store. So in this case, what we're going to be doing is we're going to be building as though our front end piece is going to be a website that lets you buy Pokemon for money, like like an actual store. So me and my friends constructed up a list of things that can cause the price to go up. Okay, and I'm just gonna create I would use Notepad because I love using Notepad because Devin Nash, but in this case I'm going to just create a txt file in here as though it was a notepad. So I'm going to name it notes.txt. Here it is. I'm going to delete this. Okay, so what I want to do... Okay, there's that. I'm dumb. Okay, So this is what the store is going to try to figure out. Okay, there's going to be a flat cost per transaction. So no matter what, if you're just getting a Pokemon, it's going to have a flat value. And then for each level that Pokemon has, there'll be a cost, and then same thing for IVs. For any moves that are not naturally learned, there will be a cost. So like egg moves or any of that kind of stuff. Anything that's not a level required evolution, there will be a cost associated there. If the Pokemon is a baby form, there will be a cost associated there. For any Pokemon that doesn't have a 50% or higher gender ratio, so for example, Pokemon where the female is like super low spawn rate or the male is super low spawn rate, those genders would be a higher charge. For legendaries, there'd be a higher charge. For shinies, there'd be a higher charge, and that should actually include mythics. I believe that the API returns a mythic like rarity type shinies. Encounter rates that are super low, so Pokemon that are super hard to find, which I don't know if there's going to be any that actually return an overall difficult spawn rate. And then abilities that might be hidden abilities, so stuff that like I'm not familiar with hidden abilities myself very much. I know that they're just stuff that can come innate on a Pokemon, but certain ones are hidden. So if you're looking for a specific one, then that would be an additional charge. And we couldn't come up with much else for that. I mean that's a lot of different variables too. So like it's usable. So that's going to be our overall goal. So now that we know what we're going to be doing with the data, we can start to build up the logic for it. Okay. There are a couple files that are by nature built into an API, which we're going to get rid of because I don't use them. The first of which being appsettings.json. Do I have? Oh, I don't see. Okay, yeah. I don't want appsettings.json. I just want launch settings. So we'll get rid of that one. We're going to get rid of weather forecast. And then we're also going to get rid of the weather forecast controller because we're going to be building our own controllers. We're also going to make a folder for services. And inside the folder, this is how I organize the interfaces because I like to separate my interfaces from my services. We're going to do interfaces. I actually had a conversation with the guy at work today because like I use interfaces at work and I know that it's common practice, but like I never could figure out quite why. Like why would you use interfaces? Like why not why not do it a different way? Because interfaces are a little bit more work, but they're not really that much more work. So in the conversation, we basically the idea was presented that with interfaces, you have a lot more ability to use the service, especially when you're talking about from programs outside of this one. It serves as what's called a contract, which you can load up into another project and call the service that way. We won't be doing any of that with this, but it's a good practice, and it is one of the solid principles, which solid is an acronym for ways to design, which basically it's a design principle that I use. I don't get all the terminology that goes with it, but the principle is basically like you want to keep separation of concerns. You want your like different pieces to handle specific sets of logic. You don't want to have, one big program or one big file that holds a whole bunch of logic, because if you make one small change inside there, it affects all of that, or has the potential to affect all of that. Whereas if you have them broke out into smaller pieces, one small change in a small piece doesn't break everything or doesn't require a rewrite of everything, because as long as you're kicking out what you were expecting to kick out in the first place, you'll always have the functionality that you wanted to have in the first place. So in the first video, part 1, I jumped into the startup file here for a second, and I had mentioned like, oh hey, we're using Swagger because it's already set up for Swagger. In the startup here, this is where we will also do what's called dependency injection. And dependency injection is really useful because it allows you to, it's a fast way to load up classes and services, but it also allows you to have more control with them and use them in the way that you want them to be used. So when we build up a service, we're going to use it, or we're going to set it up here using the interface setup that we want to use. So, so we will have to build an interface for the service we're going to use. We're also going to have to build a controller for the service that we're going to, or for the pieces that we're going to be using. So, excuse me. So for what we're going to do here, we want to consider how a front end piece is going to do this. One second, I got a cough. Oh my god. No, I don't have COVID. Okay, so from a design standpoint, we want to consider what a front end is, the steps that a front end is going to have to do, because that's what's going to determine how the logic proceeds. So if a person is looking at a Pokemon for purchase, like I said, we're not actually going to build, or we're not actually going to make this into something that can be used, but we're going to go through the process as though we were. So if you were trying to build a store where people could, set up a Pokemon and then price it out, it's kind of like building a computer. Like, you would be able to pick all the different components, put them all together, and you have a running tally of how much each piece costs and what the total is at the time. So we want to imagine that that's going on in the front end. And we probably will have to adjust it if we actually start building up a front end piece to pair up with this, which I intend to do. We'll have to adjust it as needed, but things to do that we need to do is we need to be able to query the Pokemon. The Pokemon should be able to return a list of the abilities that they can learn. It should be able to, let's see, we'll need to be able to, you don't need a query for levels. Don't need a query for IVs. You do need a query for the moves. You do need a query for this evolutions. And in the evolutions, you need to know if there's a stone required or some special, I should just say special criteria. Some special criteria, not just level. If there's a baby form, you need to be able to query what the gender rates are, whether they're legendary and mythic, shiny, encounter rates, and all that. And some of that already comes back in these objects that I built. So what we're going to do is we will build up a test controller, or just a basic Pokemon query controller, and a service that handles that, and we'll see how much of this fills in properly, what we need to fix, and what we still need to be able to get back. Okay, because like I don't have I don't have the ability class, so I don't know what the actual abilities are or the descriptions, but I might not need that. But I probably do. I probably do need that. Same thing with Pokemon Move. I have the move, but I don't have the move object built, which is a separate call. So we'll have to do stuff like that, additional building to get all that data back. So the first step, like I said, is making sure that we can get all the data, and then we'll move forward into the logic as we go. So first thing I'm going to do is I'm going to build a controller. Okay. You want to build an API controller, so that way you can actually do RESTful API calls, which is what we want to do. we're doing a Pokemon controller because what we're querying is Pokemon data. So that's what we want to build the controller for is Pokemon data. Okay. So we're gonna go ahead and build that up. I like to set this up in a different way. I feel like I'm missing pieces. Oh, what is it called? It's not returns. Hang on, let me. It is the field I'm looking for. I believe is like returns or. Produces. It's produces. I think it's produces. So let me Google this and see if that's what I want. API controller produces response type. Controller action return type. Good. It's not produces response type that I'm looking for. It is, I think it's just produces. JSON. Format response data, blah, blah, blah. Get about, version, search. But I'm not, that's not what I'm looking for. I'm looking for produces data annotation. There we go. So what I'm looking for is produces. I knew it was produces, but I didn't know what this was. It's application JSON. So what that does is it tells whatever's calling the controller, hey, this produces a JSON out of it. So when you're calling it, you need to have the JSON built that that receives it, which is what I did here. It's basically the same thing as what the API database source did. You can also do an authorize if you were wanting to do an authorize, but I'm not setting up for authorization, so I'm not going to do that. And because we're not processing any real actual money or anything like that, we're not going to worry about it. At this point, if you had any fields, I'm going to region it out, such as like a logging field, a logging system, or any of that you wanted to inject here, you could. I don't have anything at the moment, but I can get something later if I need to, so I set it up anyway. Same thing with constructor. This is just good practice stuff that I've done a lot, so there we go. These are my regions, and I region it out so that way I can minimize it and get it out of the way. But those are good pieces. So region, and then this would be your calls, or you could call it gets or whatever you're doing in this section, but we're going to do our HTTP calls here. And then this is where I needed that other one that I totally backed out of. Okay. A lot of this, like in the field, you have, or in the workspace, I guess, you have a lot of this readily handy, so you don't need to memorize it, but you need to put your path here if there is a path. In this case, I'm going to build the path of Pokemon. And then you want to make it an async, I think, maybe. Get Pokemon base. And then you'll set up what your intake is in a second. Right now it's just this. Typically you want to do an action result. So you can at least say that this was a successful or not successful setup. That's what so for those of you who aren't super familiar with what I just did here. So task it is a action, so like it's kind of similar to void, I guess. But so it returns. This doesn't really return anything. It just does this thing. But this action result is a return, and this is your HTTP codes as a return. So like you can return bad request, which is a 401 error. 401, I believe. You can do a 200, which is okay or success. If you have an object you want to return inside of that, for example, you could do an object here. Just to make sure, yeah. And then you'd build up your return object here. But right now, and I know that there's going to be, so I'm going to actually just question mark it out, so that way I know that I need to build one for return. And it'll probably be similar to the Pokemon stuff here, but I'll have it be custom, so that way I can return out only what I want to return out. And then I don't have to return out all this other stuff that doesn't help. Okay, so in this case, actually, it'll probably be a list. So I'll probably return a list of objects, which would probably be the list of Pokemon. Which makes me wonder, I should probably pull out my work laptop and get my search result object. I'll do that in a break, because I actually need to deploy some software for work. So I'll probably do that and get myself some of my other resources set up here. I didn't really launch up all the stuff I wanted to prepare right yet. Anyway, you also need to set up your intake, like what objects you're taking in. And for this call, I think that I'm gonna just have. I think that I'm not gonna put anything in yet. We also want to build stuff with what's called graceful handling or graceful failure handling, meaning that if something goes wrong in the code, you don't want your entire code to bomb out. So, like, say for example, somebody's looking for EV or whatever, and they type in EVEE. Okay, that's not a searchable name. Like you could write it in a way that that handled that and gave you the actual EV because a letter was missing and stuff. But that's a lot of edge case stuff. If somebody mistypes their Pokemon, you don't want the whole program to just be like, okay, I screwed up and just shut off. Like, you want it to be able to say, okay, that entry is bad, and I'm going to still run. You want your program to be able to still run. So to do that, we're going to do what's called try catch. Okay, what that does is inside of this class, it'll try this stuff, and if it fails, it'll catch the exception and it'll return out the exception. So in this case, we want to return bad request, which is a 400. So if anything happens here, we want to return bad request 400. It'll tell the front end piece this section failed, and boom, that's it. Okay. If you had a logging stuff, you could do like log ex.message. That's not going to work. So you could get ex.message or whatever. because EX actually holds data on what failed here. And you could even give it, you can even tell EX what to do, or what the message is. And I'll show you how to do that later when we do some exception throwing. For now though, that's going to be the setup here. At the end we want to return an OK, which is a 200. So whatever we're doing, we are going to return an OK, and this is where you would also return your object that is being returned. So depending on what the object is, you'll fill that in. You don't want to do most of your you don't want to do a whole lot of logic inside of the controller itself. You want to use a service. So what we are going to do is we're going to build up a service real quick. We're going to add new service. New service. We're going to have this be our Pokemon service, for lack of a better phrase. What this service is going to do is this service is going to handle requests that are related to actual individual Pokemon. So service for handling Pokemon related requests. This is not going to be your service for handling like berry requests or item requests or ability or move or any of those stats. You're not going to be handling any of that here. What you're handling here is directly related to Pokemon. So like Pokemon name, Pokemon type. You're not going to really query the types themselves, but you'll get the list of types that that Pokemon has. There's going to be a lot of gray area where this can be handled in one place or another place or both, but we want to specifically make this goal-oriented towards just Pokemon. So inside here, you'll need to have a method. Right now, it's just going to be a public void. We will return something. We need to do a task. We will return something, but public task get Pokemon list. Again, we're not going to do anything there. What this is going to do is this is just going to get a list of Pokemon. Sorry, setting up the try-catch. Anytime you're doing work anywhere, you do want to do a try-catch. Okay, so what this is going to do, so I didn't really talk about it in the controller yet, but what we want to do first off is we want to have the person be able to query Pokemon. And I kind of talked about like, what if they type in a name? Okay, well, we want them to be able to type in a name. We want them to be able to say, hey, I'm looking for, Dusclops or Eevee or Meowth or whatever. And that should be able to spawn up a list of Pokemon that have the letters that are in their name typed. So like, if I type EEV, it should pull up all Pokemon that have EEV in their name. But we also want to make sure there's pagination going on, which is why I was saying I should build up the return object, which I will do after the break. So I want to make sure that that's what I'm building up first. That's the first piece of logic that I've got to have. So that's that's the flow I'm going to build. So here, that's what this is. I'm going to get a list of. So it shouldn't actually be Pokemon list. It should be Pokemon or base. It should be Pokemon list. All I really want to return out of this is an object that contains Pokemon names, and maybe ID numbers or something. And then if one is selected in the front end, then we will do a separate request. Maybe not. Maybe. Let me think about this for a second. So this, will return a list of Pokemon, but it's also gonna, what we'll do is we'll have it contain all of the data. So that way when you select one, it's already got all the data that you need for that Pokemon. And then it's a lot of calls though. I think we'll do a list. We'll do a list of names. And then when you select a name, it'll say is selected, and then you'll do the query for the rest of the data. So this will just get a list of names. Okay, so we'll have the path be get Pokemon name list. So when we call it, calling the Pokemon name list, and it'll get us a list of names. So this is API call for a list of Pokemon names that match search box entry. Okay. What this is going to return, it's going to return a object containing paginated list of Pokemon. Now here's another question. If you're doing a search box and you start typing and the pop down comes up and says how many Pokemon or what Pokemon match that, do you want to have a list of Pokemon that you can keep scrolling through forever until you run out of Pokemon that have that field? Like if you typed A, do you want to have 800 Pokemon come up because they all have an A in their name? Or do you just want the top 10 closest answers? I think we're just going to do a top 10. So probably not paginated list. We're going to do a top 10 list of Pokemon that match search entry. So that's what this returns. It returns an object containing the top 10, a list of 10. List of 10. A list of 10 Pokemon that match the search entry. Okay. So, that being said, we know we need to get a string because that's what they're going to be passing in. It's going to be nullable because no, it's not going to be nullable. If it's empty, we don't want to just return the first 10 alphabetical Pokemon. No, I'm not even going to make we're not going to make it optional. You don't make the call if there's no entry. So, and I remember this one. I think it's this one. So you're gonna add that to your path. So when you make this call, you're gonna go with. I'll show you how this is constructed here in a second. Let's do this. Oops. Shouldn't be any errors now. So I should be able to just run this. Where are the build errors? Not all code paths return a value. Oh, return. Oh. Okay. So the path. I'll show you what the path is actually for this call. Over here, and I'll show you how it's constructed. Okay, so API. Okay, so what you'll do is you'll take your first part of your path here. Actually, I can just do this. Try it out. Execute. Oh, blah. A, blah. So this is the full path right here. HTTPS localhost 43666/API/Pokemon/Pokemon list /A. Okay, does that make sense? So what does that mean? Okay, well how is that constructed? Okay, well that's constructed by, first off, Okay, so first off, you're gonna have your host stuff, your local host 44.366. This is all just how it launches. I'm launching it in HTTPS. It's on my local machine, and this is the port it randomly chose. Or did it randomly choose it? I don't think it's randomly selected. I think it is assigned here. Not here. Here. It is assigned in here. Right there. So it's pre-assigned. So that's why it's picking that port, and that's fine. After that, the API/Pokemon, that comes from the controller that I built. So it picks the API. That's the API part of this route. The Pokemon is the controller name. So it's a Pokemon controller. So the controller name is Pokemon. And then from there, I know that I'm hitting this method because I went to Pokemon list and Pokemon name. So that's where this route is going. And then, so that's how I know it's running this. And I can even break it right there at the start of this function. And when I go to try it, boom, it tells me I'm in this function. Okay. And then it's not doing anything. It's just going to return OK because that's what I told it to do. So that's what it did. It returned OK. Returned a 200 code, which is success. Okay. So that's what's going on here. That's the basic setup for an API. This is where I'm going to break. I will start up in a minute with part 4, and we'll go more into this, and we'll build up our actual interface for the service, and we'll kind of work our way back out. So we're going to start in the deep end and work our way back out to the controller, and make sure that everything's working the way it's supposed to work. We'll be back in a few. Thanks for watching. Drop a like and follow before you move on to part 4.